Hi, this is the second video with respect to an introduction to Python, and this is related to the course Digital Economy and Data Analytics. My name is Eik van Vuren, and in the previous video we have looked at a very short introduction to the Python programming language, and now I would like to start with the basics. And at the moment that we start with the basics, then the best thing to start with is so-called variable declaration. Well, we should realize that Python, like many other languages, has implicit typesetting and implicit declaration. That means that unlike what you have to do, for example, in C and C++, in which you actually have to do an explicit declaration and you also have to set yourself the particular data type, that is not necessary in Python. Well, that doesn't mean, of course, that Python doesn't have any data types. There are many different data types, and some of the standard data types that we have in Python are integers, usually denoted by int. We have floating numbers, which are usually denoted by float, and we have strings, usually denoted by str, and finally we have booleans that can only take values equal to true and false, and these are usually denoted by bool. Then in order to understand what implicit declaration means, well, it means that the only thing that we need to do is to, well, name a particular variable and to give it a value. So we could do that, for example, by having this particular variable which we call myFloat, and we give it a value equal to half. Well, because of the fact that this is equal to a half, which means of course that it's a floating number, that is the reason why in the end this myFloat will actually be of the data type float. Take into account that if I would have written myFloat equal to 1 without any dots, then at that moment in time I would not have had a float, but instead I would have had an integer, so this int type that we have over here. Of course, we can also look at other data types. For example, we can look at this, say, variable that we call myString, and then at that moment in time we can introduce a string that we, of course, we then have to use these accolades that we have over here, and in this case the string that we're going to use is Groningen. Well, then we can also print our, say, our variables that we have over here, and we can do that simply by the print statement. So at the moment that I would like to know the value of my float, which is of course equal to half, then I simply say print my float. Well, we should realize that there are also other data types. We will see later on that we can get data types by importing libraries, but still there are other more complex data types for which you even still do not have to have any libraries. And one of the, or a couple of them, are lists, tuples, sets, and we're also going to look at dictionaries. Well, we could, for example, look at a list. Well, in this case we're going to declare a particular variable which we call myCityList, and in this particular situation we are going to use a list of, you could say, university cities, and these are Groningen, Amsterdam and Utrecht. Notice that what we need to do is, first of all, that we need these square brackets over here, and in between the elements that we have, we are going to have these commas over here. Well, another thing that we have to take into account over here, by the way, and that is something that we have already seen at the moment that we were at myFloat and myString, is that we use this is over here instead of what we usually use in R. Now we sometimes would like to know the type of a particular variable. Of course, we might know already that this myFloat has a type of float, but sometimes that is not that clear. And we can always find out the type of a particular variable by simply printing and then use this function type that we have over here and then simply use our variable. So in this case, at the moment that I'm going to use this part of of code over here, well, then of course I will be returned that I have a float. Most likely there will be a little bit more because of the fact that it will also say something about how much memory actually is stored in this particular float. Well, then another thing that we can do is that instead of simply declaring a particular variable and then hoping, of course, that it's going to give us the type that we want, we can also sometimes actually force Python to use a particular data type. So instead of writing my float equal to half, we can also write my float equal to, and then we use this function float over here, and then we are going to evaluate that into a half. The difference between what we had before is that now we are for sure that we are going to have a float. In this case, there is not that much of a difference between what we have written over here and what we had over here, because of the fact that we do already know that this will also result in a float. However, it's going to be different at the moment that I would have had, instead of a 0.5, I would have had a 1 here. We do already know that if we simply write my float is equal to 1, then we do not get a float, but instead we get an integer. However, at the moment that we write here my float is equal to float, and then we evaluate that in 1, then we still are going to get a float, even though of course 1 by itself is an integer. An even more important thing to realize is that, like in many other programming languages, Python does not allow you to mix up types, and at the moment that you mix up types, then you can get very strange kind of errors. That means, for example, that at the moment that we are going to look here at both my float and at my city list, then it is not allowed to simply add my float and my city list with each other by using the plus sign. And the reason behind that is because of the fact that a plus operator is actually not used for, or is at least not defined, for adding up lists and floats with each other. So therefore, at that moment in time, we are going to get an error. And the reason behind that is because of the fact that, well, we have been mixing up different kinds of data types over here. Of course, we can add up two floats with each other. So if I have another float, for example, my float number 1, then at that moment in time, if that is also, for example, equal to half, then I can add them up to each other, but we cannot do that at the moment that we have two different data types. Well, now a nice thing with respect to Python is that because of the fact that Python is so popular, it is also not that difficult to find essentially resources on the web in order to become a better Python programmer. Apart from, of course, listening to my video, you can also look at other videos on YouTube, but there's also a lot of nice, say, websites that help you in order to become a better programmer. For example, you have here W3 Schools. Another one that is very nice is Real Python. Well, I will give you here a couple of links with respect to these these websites. More in particular, I would like to give you a link here to types in order to learn a little bit more about types. Here we can also find a little bit more information about lists. Here we have more information about tuples. I haven't said that much about tuples yet, but here you can find out more information about tuples. We can also look at sets. Well, then we have to use this link that we have over here. And finally, we can also look at dictionaries. And then we need to use this link that we have over here. I would like now to go on, and I would like now to go on to the so-called NumPy library. The NumPy library we are going to use often as econometricians, and the reason behind that is because of the fact that we should realize that unlike R, Python does not have matrices. So in standard Python at least, we cannot introduce matrices. And that's the reason why we need a library for that, and that is a so-called NumPy library. Well, in order to use this NumPy library, we first of all have to import that. And that implies that our program will usually start at the moment that we would like to use NumPy by import NumPy. Take into account that from that onwards we can actually use, say, matrices. However, this might actually give you an error at the moment that you're going to run it with standard Python. And the reason behind that is because of the fact that even at the moment that you have Python installed, then you still have to install also NumPy in addition to that. Well, I'm not going to go too much into details to get that, but whenever you get an error message that Python can actually not find this particular library, then that's because of the fact that you still have to install it. Well, as soon as you have installed it and you use this import NumPy, then we can define, for example, one-dimensional arrays. How are we going to do that? Well, we're going to declare that. In this case, we are going to use a variable called myArray, and we are going to set that equal to, well, in this case, first of all, we are going to write down NumPy for this NumPy library that we have over here. Then we are going to have a dot, and then we're going to use a function called array. Then, because of the fact that it's a function, then first of all, we're going to have these, say, two parentheses that we have over here. And in these parentheses, we are going to define our array. In this case, it is a simple array with 3 different elements, 1, 2, and 3. We can actually see that as an array, but we can also see that essentially of a one-dimensional factor or one-dimensional matrix, so to speak. One, well, a little bit annoying thing with respect to this is that we always have to use this NumPy over here. And the reason why we actually have to do that is because of the fact that Python wants to allow for the fact that maybe some other kind of library that we also would like to import also might have a function called array. And that is the reason why we always have to, first of all, have this NumPy over here. Well, that's a little bit annoying because of the fact that for any kind of array that we're going to introduce, and also maybe for any other kind of function that we're going to use from NumPy, we have to then use this, say, word NumPy over here. Well, we cannot do too much about this, but we can make life a little bit nicer by doing the following. And this is something which is very commonly done by Python programmers. Instead of using NumPy, we can also use NP, but then we have to introduce, say, another kind of import. Instead of having this import that we have over here, then we are going to have import NumPy as NP. So this is what you actually find in many Python programs, that then at that moment onwards, we can use NP instead of this NumPy that we have over here. Well, that implies that if I would have done this import over here, then I could have written my array is NP array, etc. Well, then the next thing that I can do is that I can then also look at two-dimensional arrays, maybe better to say matrices, and I'm going to call a particular matrix, or I'm going to declare it by my matrix, and that one is equal to, well, again, now we're going to have NP array. And, well, again, because of the fact that array is a function, we should realize that we are going to get these two parentheses over here. But then inside we're going to get, well, actually, first of all, square brackets. Here, the first set of square brackets that we're going to have over here are for the different rows. And then the elements that we're going to have into these square brackets, also square brackets themselves, these are going to be the different rows that we are going to have. So that means that the first row that we have is 1, 2, and 3, and the second row that we're going to have is 4, 5, and 6. This is going to, well, declare for us a matrix that has 2 rows and 3 columns. Well, This is of course already quite nice, but another thing that is nice that we can do is that we can do actually linear algebra with this NumPy library. For example, what we can do is that we can multiply matrices with each other, and for that we can use this add operator that we have over here. But before I'm going to say something about that, I would like to say that like in R, we can also multiply matrices with each other by using asterisks. But we should take into account then that we are going to then do a multiplication, not as in linear algebra, but we are going to do it element wise. And that implies that what we then have to have is that the, say, two matrices or arrays that we're going to multiply with each other, they must have exactly the same size. Unlike in R, where it's still allowed to have two matrices to be multiplied with an asterisk that actually do have different sizes, that is not possible at the moment that we're going to use Python. So the two matrices have to have exactly the same size. So if I would like to multiply this matrix that I have defined over here by another matrix with using an asterisk, so doing that element wise, then at that moment in time I need to have also a matrix which is having, say, two different columns and two different rows, of course, and three different columns. But now let's go back to the real multiplying of matrices. Well, in this case, what we're going to do is that we're going to use an A matrix, and this A matrix is actually a 2 by 2 matrix. The first row has elements 1 and 2, and the second row has elements 4 and 5. And then in addition to that, we do have a vector, and that only has two elements, which are equal to 7 and 9. Well, then what we can do using this add operator is multiply them with each other. That is allowed in this case because of the fact that in this case the number of columns of A is equal to the number of rows that B actually has. So therefore this, say, operation that we have over here is allowed, and well, we can set the result equal to this x variable that we have over here. So we set x equal to this multiplication over here. Well, and you can actually check it yourself, but that gives this these numbers that we have over here. We can even do more linear algebra with respect to NumPy, but then at that moment in time we need the sublibrary linalg of NumPy. For example, one thing we can do is that we can actually invert a matrix. So what we could, for example, do is that we have here np, of course, for NumPy. Then we are going to have the sublibrary linalg, and then we are going to have the inverse over here, and we're going to take the inverse of this matrix that we have over there. Well, probably it's not so difficult to calculate this inverse by yourself by hand. However, I have not done that, but you can actually check that in the end the result that we're going to get is this thing that we have over here. Another thing that we can do is that we can solve linear systems of equations. So suppose that we would like to look at two different equations where the first equation is actually defined by these numbers 1 and 2 that we have over here. So x0, for example, plus 2x1, and then the second one is actually defined by this one that we have over here, and we are going to assume that the outcomes of these two linear equations are respectively equal to 7 and 8. Well, then we can try to solve that, and we can actually solve that by using this solve function that we have over here, which again is a function of this linalg sub library. If we are going to do that, then we do find that the result in the end is going to be equal to these two numbers that we have over here, and we can store that then into this x vector that we have over here. Well, in order to know a little bit more about this linalg library, we can look at this link that we have over here. I would like to go on, and I would like now to go on to blocks. Blocks are very important building blocks, of course, of any kind of programming language, and that's also the case, of course, in Python. However, unlike programming languages like R, C, C++, and Java, they're not going to be defined by these aglets that we have over here. Instead, at the moment that you would like to define a block in Python, then at that moment in time, we simply are going to have this double point over here. However, apart from the fact that we need this double point that we have over here that I will explain on the next slide, we also have to indent. And that is very important. You have to realize that even though it is, well, very common in C, C++, Java, as well as in R to always indent blocks, it is not necessarily the case. You don't have to actually do it at the moment that you're going to program in any of these languages that you have over here. You could actually simply put everything exactly below each other on exactly and start every line at exactly the same point. Well, that makes it a little bit difficult to read, of course, your own code, but it is allowed. You will not get any error messages if you're going to do that. That is not the case in Python. At the moment that you don't indent, then at that moment in time, you should realize that you get actually an error message. And these error messages, they can actually be quite frustrating. And the reason behind that is because of the fact that you can actually get error messages that were actually the most common error messages in Python, such as, for example, indentation error, unexpected indent, as well as top error, inconsistent use of tabs and spaces in indentation. These are very, very common errors, especially among people that just start to program in Python. But take into account that even in the case that you are already understanding the whole idea of indenting in Python, then you should still take into account that you may actually still get error messages. And the reason behind that is because of the fact that Python actually sees tabs and spaces as two different things. And that implies that even in the case that you see actually in your own code that just exactly the same thing, white space, and you do have the idea that you have been correctly indenting, that might not be the case because of the fact that Python actually sees an inconsistency between the tabs and the spaces, and therefore you will actually get this last error message that you have over here. Well, that is to say that at the moment that you're going to program in Python, it's a good thing to always use an IDE, an integrated development environment, or integrated developer environment that is actually fit for Python. So therefore, for example, never use Microsoft Word for programming. I would say you should never do that in general, but also do not use things as, for example, RStudio or Text Studio or something like that in order to do programming in Python. And even, things that are, for example, in the terminal, for example, if you're an Linux user, then you could, of course, also program in a terminal, but you should actually not do that. You should use an IDE which is fit for Python instead. And some of the IDEs that are available nowadays are Sublime, Spider, as well as Visual Studio Code. Now let's look at a block, because of the fact that we have been talking already about blocks, but we have actually not been using a block yet. But let's look at a very simple example that uses a block, and for that we are going to use a so-called if statement. The first thing that we're going to introduce in this code then is that we are going to introduce string, again my string, and in this case it's the University of Groningen. And then we are going to ask ourselves the question whether there's actually an O in this string that we have over here. Of course, that is the case because of the fact that we have one over here and we have one over there. So then the first thing that we can do is that we can then have an if statement. If O is, if O in my string, well, take into account that we do already know that that is true. So in that sense, this bit of code is of course a little bit silly, but it is a nice example at least. And then we are going to have this double points that we have over here. Then, because of the fact that we start a block, we have to indent, and that is what I've done over here. And then we print letter O is in my string. And then we also have else. Also here we start a block, so we have to start with this double point and we have to indent. And well, of course, if O is not in my string, then it actually says letter O is not in my string. Well, we do already know that in this case we are not going for this option over here, but we are going for this option here instead. Well, take a couple of things into account. Of course, we do have to have these double points over here. In addition to that, we need to indent over here. And another thing that we are going to see is that unlike in R, we don't actually need parentheses. And that's actually quite nice. And one of the reasons why we don't want to have parentheses is because of the fact that this is a lot easier to read without parentheses, because of the fact that anybody, even maybe non-programmers, might already understand what this bit of code tries to do. Well, another thing that we can do with respect to blocks is that we can use a for loop. One thing that we could do is that we can simply have a for loop that is going to, well, iterate from 1 till 100, or actually from 0 to 99. How are we going to do that? Well, then we simply say for I in range. Well, this is now going to be our iterator, of course. It's going to be for I in range, and then we get 100. This is actually a function which gives us simply an iterator from 0 to 99. It's actually a separate data type, and the question of course arises, why do we actually get things from 0 to 99, and why don't we get it from 1 till 100? Well, the reason behind that is because of the fact that we should realize that Python, like actually many other languages, actually starts to count from 0. And that is important to take into account because of the fact that that's also important in many other things that we have already seen before. For example, if we scroll back over here and we are going to go to this My City list, then a question of course arises, how are we going to get the first element from this My City list? Well, we can access that, well, by of course using square brackets. And we do already know that in R, if we would like to do something like that, then what we need to do is that we have to have My City list and then square brackets, and then we are going to get a 1 between these square brackets. But that's not what we have to do in Python, and the reason behind that is because of the fact that if we're going to do that, then we do not get the first element Groningen, but instead we get the second element, if we use a 1, Amsterdam. If we want to have the first element, then at that moment in time we should actually use a 0 instead. So then we should do My City list, and then between our square brackets we have to have 0. This is also important at the moment that we're going to, for example, use arrays. Then also the first element that we have over here in this my array is going to be the 0 element and not the 1 element as we have over here in my array. Well, the question of course arises, why does a programming language like Python do something like that? Well, the reason behind that is a little bit historical. We should realize that computers, well, actually in their own language, they only have 2 different, say, numbers. It's only 0 and 1. And therefore, if you would like to extend the numbers, it makes more sense to actually start again from 0, then have 1, and then have 2, etc. So that's the reason why most programming languages like Python and actually C and C++ as well as Java, they actually start to count from 0 rather than to start to count from 1. Actually, one of the very few programming languages that starts to count from 1 is in fact R. Well, coming back to this for loop that we have over here, well, this will of course in the end print us, say, numbers from 0 to 99. We can also use other kinds of for loops. Another for loop that we can look at is doing for loops over a list. That is also allowed. And we come back to the list that we have already seen before, my city list, which has 3 different cities, Groningen, Amsterdam and Utrecht. And then what we can simply do is introduce once again an iterator. In this case, that is this city that we have over here. And then we say for city in my city list. And then we're going to print all the cities that we actually do have in this city list over here.